This is video 2 of 3 on solving inequalities. These are a little tougher than video 1. There are 6. You can try each one before I go over it. Give number 1 a try. On number 1, step 1, simplify. The left side needs to be simplified. I have distributive property. 2 times 1 is 2, and 2 times negative 5n is negative 10n. Bring down the 8n, bring down the symbol, bring down the 20. Left side is not in simplest form because I have like terms. 8n and negative 10n combine to give us negative 2n. Bring everything else down. The variable's on one side, so I'm ready to get it by itself. To get rid of plus 2, we subtract 2 from both sides. Then, to get rid of times negative 2, we divide by negative 2. We have to remember right here the difference between inequalities and equations. If you multiply or divide both sides by negative, you have to flip the symbol, which we did. So our answer is n is greater than or equal to negative 9. Your graph should be closed circle to the right over the negative 9. Now try to solve and graph number 2. On number 2, both sides need to be simplified. On the left side, 2 times n, but let me do the right side first. On the right side, 3 times n is 3n. 3 times negative 6 is negative 18. Then we combine like terms. 2 plus negative 18 is negative 16. Bring down the 3n, bring down the inequality symbol. And on the left side, 2 times n is 2n. 2 times negative 4 is negative 8. Step 1, simplify, done. Step 2, variable on one side. When you have a variable on both sides and a constant on both sides, I like to put the variable on the side that results in a positive. So I'm going to subtract 2n from both sides so that I get a positive 1n on the right. Bring down the negative 8. On the right side, bring down the negative 16. Now that the variable is on one side, I work to get it by itself. To get rid of minus 16, I plus 16 to both sides, which gives me 8 on the left, n on the right. The symbol comes down. At no point did I multiply or divide by a negative, so no point that I had to flip my symbol. But I do want to rewrite it with the variable on the left, so let's rewrite it. N is greater than or equal to 8. The mouth opens to the n both times, and your graph should be closed circle to the right. And you can make your graphs just as simple as you want. You just need to know it's closed circle to the right over the 8. Number 3 is a word problem. Number 3 says, the normal body temperature of a camel is 97.7 degrees Fahrenheit in the morning. If it has had no water by noon, its body temperature can be greater than 104 degrees Fahrenheit. Then it gives us the formula for converting Celsius to Fahrenheit, which I have put on the screen. It also gives us the temperature of the camel of 104 degrees Fahrenheit, which we can plug in for F. Now I can leave the formula as is, but I chose to rewrite it with my variable that I'm solving for on the left because that's where I want it to end up anyway. And of course I have to replace the equal sign because this is not an equation, this is an inequality. I want it to be the temperature of the camel in Celsius is this expression, and I want it to be greater than 104 degrees. Now we just need to solve for C, and we'll know what body temperature that would be in Celsius. On this one, we subtract 32 from both sides. That gives us 9/5 C is greater than 72. To get rid of times a fraction, we multiply both sides by the reciprocal, which in this case would be 5/9. 72 over 9 simplifies to 8 over 1. 9 goes in 72 8 times. 9 goes in 9 one time. On the left side, they cancel out. That's why I did it. They're reciprocals. And on the right side, I have 8 times 5, which is 40. So the answer is the Celsius temperature has to be greater than 40 degrees if the Fahrenheit temperature is greater than 104 degrees. And our graph would be open circle to the right over the 40. Number 4 is a word problem. It says Keith's dog weighs 90 pounds. A healthy weight for his dog would be less than 75 pounds. If Keith's dog can lose an average of 125 pounds per week on a certain diet, after how long would the dog reach healthy weight? So healthy weight is the expression on the left side, and healthy weight is less than 75 pounds. And his healthy weight is the 90 pounds he is now minus 1.25 pounds per week. W, my variable, stands for how many weeks. To solve this, first we subtract 90 from both sides, which leaves us with negative 1.25 W is less than negative 15. Then to get rid of times that decimal, we divide by it. I am dividing both sides by negatives, so I flip my symbol, and I get W is greater than 12, open circle to the right, which means after 12 weeks, he will be at healthy body temperature. Number 5 is a word problem. It says, Ben has $6 to spend. A sundae costs $3.25 plus 65 cents per topping. Write and solve an inequality to find out how many toppings he can order. A sundae is $3.25 plus 65 cents per topping, and all he has is $6, so whatever he gets has to be less than or equal to $6. Can't go over. Try to solve and graph this inequality. To solve this, we subtract 325 from both sides, then divide both sides by 0.65. At no point did we multiply or divide by negative, so at no point did we have to flip our symbol. He can't have 0.23 of a topping, so the answer is less than or equal to 4. And the graph would be closed circle to the left, and the answer to the word problem is no more than 4 toppings. Number 6 is not a word problem. Give number 6 a try. Solve and graph. To solve number 6, both sides are simplified and the variable is already on one side, so all I have to do is get the variable by itself. First, subtract 10 from both sides. Then, divide both sides by -2. I multiplied or divided by negative, so I have to flip my symbol. An equation is not as big a deal for your variable to be on the right, but for an inequality, I like to always write my variable on the left. So that's going to be n is less than or equal to -6.5 or -6.5, closed circle to the left over -6.5. Thank you.